the thing about build processes is that they're kind of boring. They're very repetitive if you don't sort of automate them and there's a bunch of tasks to do. And, you know, humans aren't very good at repetitive stuff. We sort of get bored and screw it up. And computers are really great at them. That's what they're for. The other thing is that along with version control, if we automate the build, we can potentially just go and build any version of our software. So if a customer says, oh, version 69 of the software had a really nasty bug, we can go and look at it and say, okay, let's get a build and try and reproduce this locally. Now, the reason I asked about how many people can sort of do the build, there's this concept called the buzz number, okay? The buzz number is how many people have to get run over by a buzz to kill your project. And, you know, if there's only one person who can do the build, then you maybe have this situation here. So, you know, if the build is automated and it's one click, then pretty much anyone can just go and produce one. So, your version control script will probably go and obtain some source code from version control. It'll probably get some configuration. It's kind of nice to sort of keep your configuration in the version control too. It'll build it, it'll package it, and optionally, but you don't always want this, it can go and deploy it as well. Now, there's lots of tools for this. On some projects I work with, there's things called makefiles. Makefiles are wonderful in some ways, but completely arcane in others. So to sort of make things easier, there's a load of sort of GUI tools as well. Things like Final Builder, TFS has some support for this, there's one called Enant, and so on. Now, what I'd like to do is bring on my glamorous assistant, boss, Turan, and he's going to show you what Final Builder looks like.
Yeah. So, Final Builder is one tool that you can use to make build systems. And I think it's in the screen here. No, wait. So, how many of you think that it's kind of easy to make your build scripts, and how many can find it easy to make build scripts? Do you use kind of XML based or TFS? How many find it pretty easy to make a build script that takes from source control and make a deployment? No hands. Because of scattered workflows or in TFS, or is it because of XML? One. The problem with the build script is that it's kind of really hard to make the build script, and if it's really hard, it's maybe only one person in the team who understands it. And the ideal is that most people in the team should be able to go in, look at the build script, and make changes if necessary to make the product build. And if you have like an XML-based build system like MS Build, or if you have Cruise Control or Enant, the problem is that it's really hard to debug. It's kind of, how do you debug it? I mean, you can run the whole thing and see, oh, it worked or not. And it's kind of pretty inefficient and hard to debug, and you almost need to be a rocket scientist to be able to see what went wrong. So, one tool is called Final Builder. And it's actually GUI-based. There's no XML. Hallelujah.
You may have a different window shown on the screen, by the way.
Great. So, Final Builder. It's a GUI-based tool, and I want to show it as a kind of alternative because this XML build scripts is really, really hard to debug, and it's really kind of inefficient and kind of a waste in your process to have to kind of, I mean, things should be easy to understand, and if it's not easy, then you should change the tool. And the Final Builder is GUI based. So in this case, you have a main flow here of steps. And basically what this means is that it kind of builds sub-actions. So I have defined different kind of sub-actions here for different kind of operations, like we have MS build, and each task here has its own kind of property window. So you populate it with your project path and the target and logging details, framework level, like .NET 4, 3.5, project properties, and we have, for example, build a different part of the application, it builds a solution, and you can select what solution, what projects in the solution that you want to build. And this gives you a really good overview of the build script, what you do, the build process. And if we, for example, run this script now, it will look like this. Nice. It's kind of GUI. You see what's happening, and it's compiling, copying files. I mean, if you have a really complex product that has many different solutions and projects that need to be merged together, then it's really, really hard to kind of do it with an XML-based system. Breakpoints. I mean, if you have breakpoints in your build scripts today, anyone? And then I can just single step. I can go down to the disk level and see, what happened? You know, what did the file appear where it should be? I've got the build revision file here that I created from SVN, showing me the revision number and the SVN URL that I got the file from. That's useful for debugging and also for the kind of QA or production team. And I can just then, when I fix my bugs, continue. And as you see, all these steps is done by automation. And how many of you have a manual build process today? I mean, how many do you copy the files, edit the files manually? Quite a few hands here. I mean, what happens if you check in the local database connection strings and it goes live? Any ideas? What will happen? Boom! I mean, we can't allow it to happen. That's why we need to secure the deployment process so that accidents won't happen. You can't check in your local developer connection string or your local username or password or local paths. It has to be secure. So in your build process, you should be able to go into your web config and make sure it's in the correct state. I had one client that had a manual deployment process. They had a web service, and they had misconfigured the custom error settings, so it dumped the entire stack trace and source code each time it had an exception. So when I was using that API and I got an exception, and an entire 10,000 line of source code for that single page was dumped into my browser. Not so good. But the main problem was that the connection strings to the database, the username and password, was also in the source code file. Not good either. So I mean, it's easy to make mistakes, and if you really understand what the implications are if you deploy, the wrong thing to a live site, it's going to be pretty disastrous. And in this tool here, you have also kind of ready-made actions for kind of making zip files. You have build tools to make MS build, run NAND scripts. So Final Builder is more kind of generic scripting engine. It's not specific to .NET or Java. It has compilers for most common languages like C#, VB.NET, J#, Delphi, Java, or Visual Basic. And you can do database things like backing up databases and restoring databases. And you can control virtual machines. You have Git integration. You have you can start and create IS instance, and source control access to Team Foundation, source safe, subversion, and so on. So this is kind of the GUI editor part. Then there is also a web-based GUI, web-based server that acts like a continuous integration server, where you can log in, so you can see your project, and you can start a project and take a cup of coffee, and it will be deployed in a few minutes. And you can see what is running here, and you can even start a second project to build. And this time you are asked for the SVN revision number and the build URL, so you can actually go back in time and build and deploy a previous version. How many of you find it easy to go back and build a previous version and deploy it in a single click? No one? So what do you do on a Saturday evening when the customer support calls you and you have to fix something? Would it be nice to just log in and go back to the version that worked before, and maybe continue with your Saturday movie or something like that? That's kind of the ideal scenario. So I mean, the main point is that it should be easy to start builds. It should just be log into a website, click on a few builds, and even start many builds at the same time. Queue them up, and then do something else, and it can build and do the deployment for you, and you know what? Either it breaks because you have done some bad check-ins, or it completes and makes the deployment successfully for you. And if it should break, you will get even GUI-based error logs, so you can see why it failed, like some similar version attribute error in this case. So you don't have to do remote desktop in and dig into the logs manually. It's all web-based. That's the ideal scenario for a build system. And it should not be kind of XML files, and it should not be kind of hard to maintain or hard to kind of debug. And many people also use kind of TeamCity in combination with Final Builder, using the TeamCity for the kind of more continuous integration jobs, and then Final Builder doing the kind of actual scripting. But it's kind of, there's different ways of doing it. And then one company that uses TeamCity to start Final Builder builds on the Amazon cloud. So they start the Amazon cloud server instance, makes a request to the Final Builder part on the cloud server, makes a build, and then you get the binaries back to your local server. So there's many different options to do this kind of build setups. And if you have any more questions about builds and continuous integration, you're welcome to talk to me afterwards. I'll let Jonathan continue.
Okay, thank you very much, Dora. Okay, so we've seen version control, we've seen automated builds. So once we get to the point of having these in place, then we can actually go and build every commit. So the reason we can sort of do this is that we've made it really cheap to do the build now. Okay, it's one click, or even better, one thing that gets triggered. Why would we do this? Well, if we are going and thinking about our commits as changes to be integrated into the system, isn't it nice if we can actually check that each of those integrations was successful? If you do 100 commits a day, which isn't infeasible if you're breaking your commits into sort of nice, self-contained, this is one bug fix, this is kind of one feature change, and you have a reasonably sizable team, you can easily get numbers of commits like this. Then, it can be quite hard to know where the breakage was if you're doing daily builds. If you're doing a build sort of every single commit, then you can say, oh, it was exactly at this commit that the build got broken. How do you do this? Well, pretty much every version control system has this thing called a post-commit hook. It's something that just lets you run a little bit of code, or run an action, or run some program as soon as a commit gets made to the repository.